Hello guys, welcome to Talks Writers and On Demand series. In this video, we want to talk about ParaView again, and we want to see how the Python view works inside ParaView. I've been asked about it, and we want to see how it works and how we can use it to plot some Matplotlib objects and graphs out of the data structure that we have inside ParaView. Let's go for it. Yeah, I received a comment asking about how we can take advantage of Matplotlib to create some plots, charts, and graphs inside ParaView out of the data that is actually generated or is plotted inside ParaView. So Matplotlib, as you may know, is one of the most powerful plotting libraries available in Python ecosystem. We already had a video on that. And you can use it in different ways in combination with ParaView. One of the ways is you can use it outside of ParaView with ParaView Python. We already discussed how ParaView Python works and how you can use it to automate things. So you can use it in that way, call it from outside of ParaView. But there is, one simpler option, which is provided by the ParaView developers, and that's actually a dedicated view inside one of these viewports that we can have inside ParaView called Python View. And with Python View, let me show you. Let me open ParaView. With Python View, which is actually here, I divided a viewport into two, and then we have different viewports that we can create here, and one is called Python View here. With this Python View, we have this script box that can be detached and come here, that can be used to write some scripts that can be plotted inside, that can be converted to an image and be plotted here inside this Python View. But there are also some, wrappers inside the ParaView module inside Python that can handle some interaction with Matplotlib objects, and you can directly create Matplotlib objects and then convert them to an image and then plot it inside this Python View. So, the way that this Python View works, I have already prepared some scripts, some sample scripts here. I will describe them. We check them one by one here. The first one is the skeleton of the script that you need to write. So in order to write some scripts here, it's really it is not that you start to import Matplotlib and then plot it and then it is reflected here. It's not like that. You need to define two functions. One, and you can see that I put it here, and then when I click somewhere else, it gets plotted here. So it does nothing here, and that's why it is still black. And I want to say what these functions are all about. So we have a setup data and a render function. The render function is the one that does the rendering, as the name suggests, and does the plotting. So you can put whatever you like here and be plotted here. Of course, it should be converted back to VTK image data. But this setup data is an important function actually, but can be ignored for some applications. Let's say most of the applications that we may face, because it has the responsibility to get the data that we want out of the data set from the server. Because ParaView is designed for server client architecture in mind, meaning that you will have huge data sets loaded on a server, and then you get some data out of it rendered on the client. So ParaView is really efficient for doing this kind of communications. And as a result, when you have the Python view here, there is a mechanism, which is this one, that you can use to select the data that you like only, that you need to have access to inside this render, let's say a function, which comes from this view to that. And then the width and height is actually the size of the image. So it comes from the width and height here. So sorry. I was saying that the setup data is intended to be used as for that purpose, that you want to get some data and you don't want to fetch all the data from the server because it would be very slow if the data set is very, very huge. So this is actually the skeleton that I copied here. That does nothing, but we want to have, we want to do something for it, which is actually this script. But for doing that, let's create some, some objects here. As always, we go for, this wavelet source, which is actually my favorite source because it allows us to have some sources of data here. You see that we have RT data, and then I can have like the surface. You can see that these are the data of that. And then I can use this script. So what it does, before I copy that there, you see that still we pass. We have no definition for setup data because I want to have all the data being copied to the stream, let's say, back to the client. Here, server and client are on the same machine, so I don't care. And then I have the Python view from the ParaView module, and then figure equals Python view, which is actually the Python view that we have, and then Matplotlib figure. As easy as that, we have access to Matplotlib, and this is actually the wrapper that I said is available inside the ParaView module with the width and height that they come from here. And then I can have like subplots, different subplots, and this is a really simple Matplotlib code. Please refer to the video of Matplotlib, set the title, X and Y. And here it does the important thing, an important thing, which is actually getting the visible data object from here. And so here I make it visible also for the Python view. So this is, some errors that we always get. But we can safely ignore it. And then I create some example data out of the data that is available inside this visible object, which is now inside this data object. I say get points, get point data, all the point data. Now you know that this icon means that it's a point data. And then get array RT data. That's the data that we want to get. And then we convert it to a Numpy data structure. We have already discussed Numpy. Please refer to that video if you don't know what a Numpy is. But Numpy is actually similar to MATLAB interface in Python for numerical computing. So from ParaView Numpy support, we import VTK to Numpy because X is actually VTK data structure, and then we simply converted VTK to Numpy X with the name MPX, and then we can use Matplotlib histogram feature to plot it with like 20 different seeds or bins. And then in the end, this is very important. If you don't want to use Matplotlib, you can always use, a function like this to convert the figure to image, or you can directly start to create an image or whatever. But the output should be in the VTK image data format. And this function does that for us, converts the Matplotlib figure to something that the Python view can handle. Let's copy this and see the magic. So I select the Python view again, I detach it, and instead of these functions, now I actually fill the render. And then you can see that how nice it is plotted here. This is quite nice, actually very nice, showing that how we can use actually Python view, how we can use Matplotlib inside ParaView using the Python view interface. So that's it. We read the first object and we get the data out of it, like in this case RT data, and then we can do whatever we like. So now I want to add a new subplot to that and create some histogram, some line plots in Matplotlib. So for doing that, I create a line plot first here in let's say ParaView. So it is really like this. I don't want to have it there, so I divide this one to 2, and then it will be a line chart view. You can see it here. So if I select this one to be like the outline, and then plotting this, so this is actually the line that I was referring to. So this is the line, and then when I select it here to be plotted here, this is the type of line that I want to reproduce in Matplotlib as well. So with selecting this one and coming to this graphic view, I can see that it has RT data and arc length. So what I can do is actually, this is the third script, but we can modify the script together. So the second script, I modify it and then I copy it back to the script view, so to the Python scripts of ParaView. So what I need, I change the name of the access here. It should be also like this, access 1 histogram, and then yeah, that's it. And then I need to add a new I want to make it like 2 subplots, so it is 2, and then 1. I think now it should work nicely. I can always go back to ParaView and check the script. So now it does nothing but adding a new subplot here, which is actually not filled yet. So with the same logic, I can create a new subplot, which comes here after this. So now I will have like a new subplot, which is actually subplot 2, axis 2, sorry. And then it should be number 2. As simple as that. And then it can be like subplot 2. If I copy that back, you can see that now at least the container, the placeholder is created for me with the plot title too. And now, instead of this one, I would say data object line. I will call it data object line, and then I will get a second visible object. I come here, the line is visible here, and then I get it as the data object line, and I can do the same thing. So here, I would say X line and probably Y line. So X line and then Y line. I want to read both the X and Y of these objects. So it's Y with RT data, and for this one, it is arc length, which is actually what I showed you here, which is this one, and then the arc length. So I go here again. So I need this to be open, and then I have read this 2. But what I need to do is converting back to some Numpy structure, which can be done like this, MP line X, I would say. So MP line Y, and it should be like X line and then Y line. So I converted to that, and then these are ready to be plotted. And this is actually, I can use x2.plot and then np line x actually versus np line y. And that's all I need to do, I think. But there is one thing here that, this is actually where we need to do something with setup data, because if I don't add a line here, it may become problematic because I won't have access to the second object, which is actually accessed here. So I need to add a line here, which is actually enabling all the attributes. So I need to improve the indentation, to correct it, and then that's it. We enable all the attribute arrays. There are also some interfaces like this. I have commented it here, which you can iterate through visible objects and get only the data that you want. Here it is, XXX, but instead of that, and it is actually point data, instead of that, you can get the data that you like. You set the attribute to active, and then that means that please transfer it from the server to the client. So, yeah, I think that's all we need to do. Let's copy it to ParaView to see if it works or not. No. There are some errors here. It's okay, because then we can see the problem. If there is any problem here, it says the non-type object has no attribute get data line, script line 36. So we can go to the line 36 to see the problem. So 36 is actually this one. It says that X line is empty because it doesn't have, oh, I'm sorry. It's because of the data objects. I should read it from data object line and not the data object, because the data object is the first visible object and it doesn't contain arclen. So that was the error of this script. But you saw that it's not scary. It's really small Python, like, you know, a familiar Python output error message that you can see. It says the line number and it tells you the error, so it should always be easy to fix. And now we have this super nice this plot, which is very similar to the plot that we have from the ParaView itself. So yeah, this is actually the way that you can plot it, but there are you know, other features that this brings, actually, because you have access to, you know, some Numpy features as well. You can use Numpy to do whatever you like. And as an example, you know, as the final example that I want to provide you with in this video, I want to show you how you can do some interpolation here. So for example, if I reduce the resolution of the line to 50, I press OK. You see that now we have a line like this, which has only 50 values. And then I want to use some interpolation features of Numpy to do some interpolation inside using this data. So I don't want to write the code right now because it takes some time, and instead I have the script here, so you can see that that's the same script. And then we plot the data with a line with O this time, which means that put dots there. And then we have X interpolation, Y interpolation, X interp, and Y interp, which is the X is a linear space, linearly spaced points with the minimum of the X line, which is actually because we want to have this. You should always try to write the scripts as general as possible, and in this way, I read the beginning, the minimum of the line, the beginning of the line, and the end of the line automatically in Python again, instead of some hard-coded values. And we have like 100 points here. And then I use np interp function. And np is Numpy. I forgot to say that we have here Numpy imported. And yeah, that's it. So we can easily use this line to interpolate the values in these 100 nodes that we have created. So we did npx line and npy line, which they are coming from this. In this case, there are 50 points coming from ParaView. I can interpolate it and then plot it on the same subplot axis 2 with red, with the dashed line in red. So let's copy this one and see the output. And then you can see that actually we have some, as I said, this O, which is actually it's here. So O points. So these are the points coming from ParaView, and then the red dashed line is the one interpolated by the Python View interface by Numpy, actually. So even if I reduce it to 10, you can see that this is actually how this interpolation is taking place. And I can go back and, you know, even modify some properties of the wavelets. For example, changing the frequency in the x-axis. You can see that whenever I change something, all these things are changed automatically. The Python script is created again, is executed again, and then yeah, that's what's happening. So yeah, I hope you also found it super easy to do this, to work with this Python view inside ParaView. That is very powerful, gives you access to features available in Numpy and even SciPy in Linux. In Windows, SciPy is not supported, so I could write some codes in SciPy to do better interpolation. You see that this is linear interpolation, but it's also possible to do some cubic interpolation, for example, in SciPy, which has more sophisticated interpolation routines. But yeah, this is generally all the structure that you need that you need to get started with to plot some Matplotlib objects inside ParaView. And if you know Matplotlib, there are a bunch of examples in Matplotlib gallery. I showed you those examples in the Matplotlib video. If you know that, you can use this interface to create any plot that you want. Instead of, I showed you before, instead of like I can divide this into two and then have some spreadsheet view, and then line this actually plot over line is selected, so I can have all the data for this line, and then I can export it to CSV format and then open it in spreadsheet view, in a spreadsheet program, or read it in Python and do the post-processing. This is one option, which is more cumbersome, but in this case, you see that you have direct access to all the data inside ParaView, and you can apply that to any graph that you want in Matplotlib directly. So yeah, I hope you enjoyed the video. See you in next videos. Bye.